All right, another method of solving quadratic equations is called completing the square. This is useful particularly in our geometry class when we deal with equations of circles. So let's take a look at this example. We have x squared minus 20x plus 24 equal to 0. So one way you know to do complete the square is that this cannot be factored. So 24, the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. So none of those are going to combine to get me to 20. So we use a different method now where you can actually kind of take square roots, but we have to rewrite it in an equivalent equation, and it's called completing the square. So what that involves is the first thing is what you want to do is make sure to get the c term to the other side of the equation. So we're going to move the constant. Remember, the constant is just the c term. So I'm going to subtract 24 on both sides of this equation. It'll be easier to see what we're working out with to complete the square. So now what completing the square is asking is, can I do something to the left-hand side of this equation? Can I add a number here where I can rewrite this into a different form? And the way you do that is you look at the b term, you cut it in half and you square it. So you're going to take the b term divided by 2 and square it. So you're going to take that number and add it to both sides of the equation, and take a look at what happens when we do that. So in this problem, it'd be negative 20 divided by 2 squared. Negative 20 divided by 2 is negative 10. 10 squared is 100. So if I add 100 to both sides of this equation, I'm going to do x squared minus 20x plus 100. This is an equivalent equation because I have not changed the value, or I've made it the same on both sides of the equation. But then take a look at the left-hand side now. I can rewrite that in factored form. What numbers multiply to 100 and add to negative 20? Well, the idea of completing the square is that I can use the perfect square for 100 and write x minus 10 twice. Over here I can combine, so now this is an equivalent equation. And then x minus 10 times itself is x minus 10 squared. So here, if you complete the square, you can then go ahead and start using square roots to start solving. We're going to see it with equations like with circles. So it's going to be the same process. We're just moving the constant value to the other side of the equation, and then we're focusing on the b value, taking half of it and squaring it, and then adding that to both sides of the equation. Doing that is going to help us because now think about our equations of circles. Like if this was the part of the equation of the circle, I could know the center of the circle is going to be at 10. So if that's an equation with circles, that's where it's useful for us. So let's take a look at example one that you might have remembered from your test earlier. So we have completing the square is useful with circle equations, not in standard form. So remember, standard form for circular equations are when we have equations that look like this, and we know where the center is, and we know what the radius is because of that equation. Remember, the center is just h comma k. If you don't have equations in that form, you can turn them into that form, and then you can tell us the center or the radius of that circle. So for example, let's say you have an equation like this. All right, the first thing I'm going to do is I'm going to group the pieces of the equation together that have the same letters at least. They're not like terms, but they have the same letters. So for example, I'm going to just shift. Remember, with the commutative property of addition, doesn't matter the order you add things. So I'm going to put the x squared with the 8x. So it's going to be x squared minus 8x plus y squared minus 20y plus 52 equal to 0. And so what we're going to do is we're going to complete the square twice. We're going to complete the square for the x values, and then we're going to complete the square for the y values. So I'm going to do the same thing as we did last time with completing the square. I'm going to move the 52 to the other side. So I'm just going to rewrite this equation. To move 52 to the other side, I have to subtract it. All right, so now let's look at these in pieces. We're going to follow that same step. For the x squared equation part of the equation, excuse me, the b value is -8. So remember our step from above, you take half of that number and you square it. So I'm going to take half of -8, which is -4, and square it, gives me 16. So on this side of the equation, I'm going to add in 16 to keep my equation balanced. I do the same thing with a -20 for the y squared. So take half of -20, which is -10, square it, that gives me 100. So make sure you're adding 100 to the other side as well. So again, what we did was we took the b value, cut it in half, and squared it. We also did the b value with the y part of the equation, and we added those numbers to both sides of the equations. The reason for doing that is because now if I look at this part, I can factor this. What numbers multiply together to give me 16 and add to -8? It's x minus 4 twice. What numbers multiply to 100 and add up to -20? It's y minus 10 twice. Then on this side, you can combine your like terms. So you're taking -52 plus 16 plus 100. So if you put that together, you should get 64. All right, so I can rewrite the x minus 4 twice, which becomes x minus 4 squared, and then the y minus 10 twice is y minus 10 squared. Equal to 64. And so now the completing the square method is really helpful because I can tell you the center of this equation for the circle is 4, 10, and the radius is 8 because the square root of 64 is 8. So we're just going to practice kind of completing the square and using that to kind of help us with our equations of circles.